Okay, this will be our last hypothesis example for section 8.2. So we have Samuel, we're going back to the Morse code stuff. So he had determined that the percentage of T's in the English language in the 1800s was 9%. A random sample of 600 letters from a current newspaper contained 48 T's. Using a significance level of 0.05, we want to test the hypothesis that the proportion of T's in modern day has changed from what it used to be, the 9%. So let's write our null and our alternate. What would be very boring is if it is still 9%, what it always had been. What would be interesting, or what we are trying to show, is that it has changed from that, so that it is no longer 0.09. Again, we are not trying to show that it's more or less than that, simply that it has changed. Do we have enough evidence for that? They didn't tell us, again, in this one, but we can calculate it. Our p hat, what's our sample proportion? In this sample, it was 48 T's out of 600. And if you divide that out, you get 0.08. So not a huge difference, honestly. We think it was 9%. We're trying to show it was something different, and our sample showed 8%. So a little bit different, but not a lot different. So I don't know if this is going to be enough evidence or not. Again, we're going to use an alpha of 0.05. Again, we're using the z-stat because this is all about proportions or percentages. I need to go to StatCrunch and do this, so I need to have my number of successes and my number of observations. So it was 48 out of 600. That's what I'm going to tell StatCrunch. Stat, proportion stats, one sample with summary again. Successes, observations, change my hypothesis statements. So we have, it used to be 0.09, and we want to know, is it different from that now? Again, we can plot that if we want to, compute it. Record our z-stat and our p, and then make our conclusion. So based on those values there, I'm going to go back and write them down. So the z came back as negative 0.86, I'm going to call it, and the p was 0.392. Okay, now we've got a really big p-value this time. So since the p compared to 0.05, it's much bigger this time. So since p is greater than alpha, we need our longer sentence for this one. We haven't done one like this yet. So what this says is that we are going to fail to reject the null. We did not find enough evidence this time to toss this out. So we would have to say something like, there is not enough evidence to show that. And what we were trying to show that the percentage of T's has changed from 9%. So we failed to provide enough evidence of what we were trying to do. So we have to just conclude that it's still 9%. We haven't been able to show otherwise. So if we think about what this one would look like, this one was two-tailed, right? It was a not equal to. So both sides at 0.86, so positive at 0.86 and negative at 0.86. Beyond those values get shaded, and that represents our p-value. So you can see here that what that means is about 39% of the area under the curve is shaded. That's how that kind of ties together, and we can see that same image can be shown to us in StatCrunch. So something you just want to keep in your minds that you always want to remember is that when your z is closer to 0, right? When your z is further in, closer to 0, that's going to give you a larger p-value. When your z's are in toward the middle, then what's left to be shaded beyond them gets bigger. Your z's farther from 0 give us smaller p's. But it's the p-value that we always look at in order to draw our conclusions.